Okay, I'd like to welcome you back. Looks like most people are starting to stroll in and get on. So I'd like to formally welcome you to the first webinar of IT Basic Fundamentals, or as we like to call it, short form, just IT Basics. This is a short course that's presented by IT Masters here in Melbourne on behalf of Charles Sturt University. My name's Shane Murphy, and I'll be your MC for this webinar and for the duration of the course, which, by the way, is only 2 weeks, and I'll talk more about that in a minute. Your mentor tonight and next week will be Matt Constable. He's been with us for many years, and he knows all this stuff back the front, upside down, in all sorts of ways, so you're in for a bit of a treat there. Tonight and next week are all about going over some basic concepts for IT for people who may not have studied IT before or may have felt they're a bit rusty, particularly if you're looking at embarking upon a more rugged course in one of our postgraduate courses, a graduate certificate or a master's. For wherever you're watching this from, and I can see there's people from all over the world, we hope you are safe and well, and it's not too early in the morning or too late at night for you. But before we get into the guts of things, a bit of housekeeping. Both webinars for this course will be held at 7:30 Australian Eastern Daylight Savings Time. That's Sydney time as a shortcut. With recordings will be made for those of you who cannot attend on any given night. Despite the recordings, if you can make it, it's really good if you can come along live. It adds a bit of sparkle to everything, particularly as we have a collaborative environment and there's a chance to ask live questions. There are, as I said before, only 2 webinars in this series. It's a bit unusual in our normal run of 4. A second batch of 2 on a similar theme is planned for later on next month or the month after, which will cover some of the adjacent IT principles to the ones covered in this, which will primarily focus on networks and a bit of introductory cyber. Just to be clear, these seminars are unlike our normal ones in that they don't qualify for credit towards an IT master's subject like our other short courses usually do, because they are introductory in nature. Obviously, we use Zoom for our webinars, and we really encourage people to ask questions in the Q&A session, and we will answer them both live and sometimes in a written fashion. Please don't put questions, if you can avoid it, in the chat, because the chat flashes past so fast we often don't get to see a lot of it. And I can see it's 3:35 a.m. here for Mike Alicia, and I'm apologize that it's up so late, but you know, that's the world for you. But yes, if you can ask all the admin type questions in the chat only, but essentially the course content in the Q&A section. You can chat with the panelists or to your fellow students as well, and you can make that choice by toggling through the drop-down box once you've opened the chat log. There's often very experienced attendees who will be helpful with any queries you have, so a lot of the other chatters will chat back to you and tell you, and their insights will often augment what goes on in the course itself. We will have Q&As at the end of the webinar, or if something looks like it's particularly relevant, I might even interrupt Matt during his flow. For those who've never taken part in a short course with us, first of all, welcome. IT Masters, we're a training organisation here in Melbourne that exists as a partner to Charles Sturt University, who we work with to create and deliver a number of master's courses in IT-related subjects. We also market those courses on their behalf and hope that the best way to do that is to give some of them away for free. If we do a good enough job, then as students, you'll be encouraged to enroll in a different course if it suits you and you're liking the way we do stuff here. With that said, we want this course to be useful and rewarding. We want you to learn some interesting information, have a bit of fun, and hopefully make connections with some of your fellow students. To date, nearly 3,000 people have enrolled in this course. I think it's about 2,850 or so. And so you're spoiled for choice in that area. And in terms of our team here tonight, Kit French is around tonight in an administrative and technical support role. She is responsible for the Moodle website, the learn.itmasters.edu.au, which is where you'll find all the other materials hiding for this course. Once you're in there, you can see all the links to readings, discussion forums, and quizzes. If you have any questions tonight or later on, please feel free to contact us using the details on that page. And Lily is also here, Lily Nguyen, and she's in training for the same sort of tasks as Kit. And over time, both Kit and Lily will moderate the courses in different ways and different times. So that's all the housekeeping out of the way, and it's now time to welcome Matt, who I'm sure many of you will know if you've done any of our courses before. I'm pretty pumped to have him running another short course with us, and he's a good friend of ours. So how are you, Matt? Or do I need to say Matt?
Much better, Shane. You've got me. Well done with the three names. Hello, everyone. I won't leave the camera on all evening. Otherwise, talking with my hands will just possibly distract you. But I just wanted to allow you to put a face to the name, as terrifying as that may be for many of you. Now, with that said, I'll turn off my video so you can go back to your leisurely listening. But welcome everyone to this first week of our introduction to information technology short course. So this evening we are going to have a look at just some really basic fundamental IT concepts that will hopefully, particularly for those of you that are coming from a zero knowledge background, hopefully it will enable you to start to get some understanding of computer technology and where it will fit in a business sense or a career sense. And then next week, so this evening will probably go for about 60 minutes, usually pretty good on time in the first week. I will warn you, however, that next week we're probably likely to go over because we're looking at both networking and cybersecurity, both of which in and of themselves independently, you could spend many years of study on both of those, but we'll only scratch the surface with some of the information we're going to be looking at. I'd like to certainly encourage you to ask as many questions through the Q&A box as we go along. The ladies are here to help moderate with that, and Shane as well. And obviously, if there's something important to come up, that they will interrupt me. Shane in particular can interrupt me at any time if there's something come up. Otherwise, please, I hope that you get something out of this. I hope you enjoy it. I'm slightly whimsical the way I talk at times, and sometimes I go off on a little bit of tangent to give you as much as you can, but hopefully you'll get something out of it and hopefully you'll enjoy it. So with all that said, if we're ready to go, Shane, I'll get started if that's okay. That good?
Yep, lights are green, mate.
All right, let's go
All
then.
yours.
Okay, so a bit of boring stuff first. That's me. I'm a bit of an old fella, as you would have seen from my ugly head on the video. Been in the IT industry for quite some time, worked in a number of different spaces. So I've had a security hat at different times, networking, a help desk, server, so mid-range type stuff, IP telephony, wireless, so on and so forth. But that tends to happen when you're in industry for that length of time. And the interesting thing about the IT industry is that it's constantly evolving. So if I give you an example of, some of the jobs that I was doing when I first started in the industry 30 years ago, just over 30 years ago, now no longer exist. And, the things that I've been doing in the last 5 to 10 years and are currently doing, it didn't exist when I first started. So it's always evolving, it's always changing. And it's one of those industries where you can spend an awful lot of time in upgrading your skills and moving forward. So there's lots of opportunity to move around from place to place. So as I said, I started in help desk type support. So doing basic, help desk, printer and PC type support and repairs, and then moved into server operating systems, which we'll talk a little bit about this evening, and then moved into networking, and then cybersecurity, and then back into networking, and then into cybersecurity again, and then a little bit of wireless for a few years, and then IP telephony and contact center, so call center type stuff, and now sort of come full circle and gone back to security consulting in the present time. And then, so on top of that, then I've spent the last 16, 17 years with IT Masters and Charles Sturt Uni, teaching a number of different subjects, primarily those ones listed there. So cybersecurity fundamentals, practical internet networking, of which we're going to talk a lot about next week, and forensic investigation, and quite a few short courses as well over that period of time. Having said all that, I don't have the answers to absolutely everything. And this is a thing about the IT industry. It's one of those industries that you can spend literally a lifetime in, and yet you will never exhaust the subject matter. There will always be something more to learn. So please never stop looking for opportunities to learn, and never stop looking for those opportunities to grow and potential paths into other areas that you may never have thought would have existed. It's an interesting, fascinating industry to be involved in, and whether you're in it already and just starting off, or whether you're looking to transition, I wish you all the best. And just best advice I can give is never give up and keep persevering in whatever you're doing. All right, with that little preamble out of the way, let's have a look at what we're going to talk about tonight. So we're going to look at some basic ideas about what IT is and why it's important in a contemporary world. We're going to look at some of the fundamentals around software and hardware, and look at some common computing devices, or common, not only just computing devices, but devices that you might not necessarily think are classified as compute devices, but are. So and by the way, when I say compute and computer, to me are basically the same thing. So don't let those two things to confuse, and that will become more clear as we go through. And then lastly, we'll finish off this evening by talking about what some common applications, so common software packages that you'll often encounter. Or some of them you will have encountered already, and others you will encounter as you progress throughout your IT life. So why is IT and why is it important? Well, IT simply stands for information technology, and it helps us to make use of hardware, software, services, and then other supporting infrastructure. So things like switches and routers and firewalls and those sorts of things, which we'll talk about next week. And it allows us to manage and deliver information as data, voice, and video. And so there's a big, and this has been around for quite some time, but one of the principles which we talk a little bit more about next week is a thing called unified communication. And that is using our IT systems, our information technology systems, in all their different ways to not just work with data, so files in actual information in files or in stored areas, but also allow us to implement voice and video over the top. So obviously we're doing this tonight via video conferencing. So you're hearing my voice and seeing the video when I turn it on, hello, via a network, okay, which, 20 years ago, 25 years ago was all new and exciting and very difficult to manage and work, and was only really available to top level organizations who had a lot of money to spend. Whereas now anyone can download a Zoom client, or Microsoft Teams is another package that you can use as well, but there are many, and you can easily download it, install on your system, and talk with your friends across the other side of the world. So it's enabling people to keep in touch so much easier than what had been in the past. Information technology also involves the study and application of compute or compute devices that store, enable us to retrieve, to transmit, and to manipulate data to form some sort of information. So if you think of it really simply, data are just discrete bits of ones and zeros, really, combination of ones and zeros. And in order for that data to become information, we need to manipulate it, process it, interpret it in some way. And IT systems help us to do that much more quickly than we could do on our own. IT can also be referred to as ITC, Information Technology and Communications. And this is a term that has become more prevalent over the last sort of 10 years. I'm a little bit old fashioned, and I just like IT. ITC is about, it talks about what we're going to be talking about, information technology, and the communications part is around telephony systems. So traditional telephony systems are now branching into IP telephony systems or network-based telephony systems. And to my way of thinking, they are still very separate things, but ITC is something that you'll commonly see as well. So either of those are interchangeable, but in this, over these couple of weeks, you'll hear me just say IT more than ITC. So in 1958, the Harvard Business Review described information technology as consisting of these three parts. So the ability to perform computational data processing, the ability for decision support. So that is to support decisions that people may have been making in business or in industry. And the last component was business software. So the underlying software that enabled those decisions to be made based on that computational data processing. Now, this is a very broad definition, and we could, of course, expand that to refer to anything related to information or computer technology, including things like networking, which we'll talk about next week. So switches and routers primarily is what we'll look at next week. Hardware, so all our laptops and our BYO devices and our desktop machines and our servers. Our software, so the operating systems and applications that run across all of that. The internet, of course, or any person that's working with any of those technologies, because remember, it doesn't matter what technology you have, it's been designed by a human. It's had some input from a human, either to make it operate or to design it in the first place. And so we are still, as human beings, still part of that information technology chain, although it's not often thought about. We tend to think of technology as being those whiz-bang gadgets that we play with, but really it comes down to the people that are using it intelligently. Now, yes, artificial intelligence and those sorts of systems are making great strides, but at the moment, they haven't become, thankfully, sentient. So they're still within the power and control of the humans that design them. But that will no doubt change over the course of history. Of course, most organizations of any size will have dedicated IT departments to manage all of these systems that support these three parts and deliver services to the business or the customers of that particular business. Now, some small businesses don't. They might have a single person that does everything. If you're self-employed, you might do everything. But chances are you're going to integrate with or interact with IT technology at some stage during your day. So why is it really important? Well, because in the current day world, the importance of information technology simply cannot be understated. It is present in every facet of our lives and has become so integrated into the fabric of our society that arguably it's as vital to keeping the balance in our lives as food and water are to basic survival. And if you think I'm making that up or exaggerating that, try turning off all the electronic devices that you own and see how that impacts your day. Turn off your electricity and see how that goes. And this is an interesting one I often use in a business sense as well, is that many businesses see IT as being a cost center. So something that they have to invest in and it's costing them money and it's not really driving any benefit. That's so completely wrong and outdated, it's not funny. And I say to people who say that to me, well, I'll come along and turn off all your networking equipment and all your servers and all your desktops and see how your business runs after that. So we've got to a point in history where if all our IT systems in a business were shut down and unavailable for any period of time, businesses would simply go out of business. There would be no way for them to trade, to reach their customers, to sell their products. And that's even looking at something really simple, for example, like a cafe. Okay, you might think, well, a cafe could get by. You take down their FPOS machines, their funds transfer into their bank, their ability to, for a long period of time, to take and accept cash, and you think of the use now of cash in particularly our Western societies is starting to diminish, and it's more around card or internet banking, then it's going to make it much more difficult for those businesses to survive and thrive in the way they do now. So IT is really, really an important component of our contemporary world. IT supports businesses, all levels of government, defense, health, education, finance. Well, you can read those industries there. Everything. Every industry is somehow connected to IT. It helps businesses connect together. It opens up markets for us. Before the advent of the internet, we had a very small market. Businesses had a very small market, either in their local area or maybe in their state, or maybe if they were really lucky, maybe interstate as well if they're a bigger business. Whereas now, with the advent of the internet, many years ago now, granted, and our reliance on IT infrastructure, we of course now open up these massive global markets. I could be a single one-man band type show selling some sort of product out of my front room of my house, but I've got a web presence, I've got a web store, and all of a sudden now the whole world is my marketplace. And so it just allows us that huge global reach that just brings in so many more customers than what we would, in the past have access to.
Look at this course, for example. We have people from all over the world participating equally.
Absolutely, and even with the regular subjects that we run in our grad cert and masters programs, it opens it up to so many more people. I mean, Charles Sturt Uni is one of the biggest online student providers in Australia, if not the biggest, probably, and so opening up that space and that opportunity for education to the whole world is an extremely valuable and important commodity. And of course, most facets of our lives are controlled by or stored on an IT system. You think of how many places you're registered with, whether it's government organisations, places you like to shop, the gym, places you go to school, places you go to work. Everywhere you are a number or an entity on an IT system somewhere. And I was speaking to someone a few weeks ago, and they asked me how difficult it would be if they wanted to erase their identity from every single digital platform they could be on, and it branched into a really long discussion about how difficult that would be when you consider how many systems we have now become a part of in our contemporary world. And of course, as I said before, we rely more on IT systems now than at any time in the history of humanity. And now with the advent of the Internet of Things and the Internet of Everything, so that is, everyday home appliances or everyday sort of electronic pieces of equipment that are now enabled to connect to the internet and provide us with communications or provide us with access to things like Netflix or Stan, or to provide updates to the software. For example, on our televisions, you can get refrigerators and other white goods that will connect to the internet. You can get refrigerators that will connect and send an order to your supermarket if you're running low on milk or something. You can program them to do these things now. There are so many other exercise type equipment as well that, for example, bike trainers, for example, and smart bikes that connect to the internet to allow you to stream your performances and compare your performances to other people all over the planet. So there's lots of, and I'm sure you out there can think of a lot of other examples too, of IT systems that really, provide us with a wealth of information and opportunity that we've never had before at any other time in human history. The other thing is it's impossible now for any child born today to avoid information technology, and that is only going to become more true. When I was born 50 years ago, there wasn't a whole lot of IT around. And in fact, I didn't hit the first computer. I didn't see my first computer until I think I got to year 10 at school, year 9 or 10 at school. Whereas my children, who are now 19 and 21, when they first went to kindergarten, there was Apple iPads and iPhones and computers everywhere. So it's a totally different world in which we live in. And I think that's why courses like this are really important to those of us, particularly over 40, in being able to, who have come from other industries outside of IT. It's all right for me, I've been in IT my whole life, but for those of you that haven't, being able to come and do this sort of course is really important, to have those opportunities to build up those basic skills, which kids nowadays take for granted.
I hate to tell you this, but my first computer experience was in year 8 or 9, and we sent punch cards away to a computer that lived at the university, and then we got them back 6 weeks later. And if you punch one card wrong, nothing worked.
That's right. That's right. That is a very, very good point. When I first started at university, we had there was still tapes and ribbons involved with some of the larger devices that we used to program. And yeah, things have changed an awful lot. So yeah, well, we're of a similar vintage, Shane, so I can certainly see where you're coming from. All right, so that's the importance of IT. So it's in everything we do in life. And so we cannot understand, and we cannot understate how important it is. And I cannot understate how important it is for everyone to have some basic knowledge of some sort of computerized system. So now let's go and have a look at some of the hardware and basic hardware and software concepts that will help us to understand the basics a little bit better, but also help us to lead into what we're going to talk about next week when we look at networking and cybersecurity. So in simple terms, really simple terms, there are two categories of software. So there is system software that operates our devices, helps our devices to run and to be useful. And then there's the application software, which runs on top of the system software and is dependent on it in many cases. And that allows us to derive some functionality out of that particular IT system, whatever it is we're looking at. Now I will say there are lots of different ways to categorize software as there is to categorize hardware. And even within each category of hardware, there are further ways to categorize them, and same with software as well. And we'll sort of break that down as we go along over the next couple of weeks. But we're looking at top level here, okay? So we've got system software and application software. It's probably the best place to start. So system software, it simply includes the programs that manage the functions of the digital devices that make up an IT system. So whether that's a laptop or a desktop computer or a smartphone or a tablet or a server, all of them will have to have some sort of system software operating on them in order to be useful. Otherwise, they're just a whole heap of bits and pieces of plastic and metal that really don't do anything. Without a piece of software, a system software on them, they're useless to us. So for our purposes, system software will include two main components. The first one is called, and I'll just turn to my laser pointer because I love to use the laser pointer. There's the basic input-output system known as the BIOS. Okay, so if you hear me say BIOS, that's what I'm talking about, basic input-output system. And what this does is it allows the hardware device, so the laptop or the desktop or the server, to safely initialize and get the hardware, confirm that all the hardware bits and pieces are working and able to come up to an operating state. So in other words, you haven't got anything that's broken, everything's working. The operating system will then run on top of that. So the basic input-output system starts, checks all the hardware to make sure everything's working, and then it loads the operating system in simple terms. And the operating systems provide and control the primary functions that that piece of hardware is going to deliver the user. Okay, and some examples of operating system include these ones here. So Android for our smartphones, Windows 10, and all the other branches of Microsoft Windows that have occurred over the years. We've got a thing called Ubuntu, which is a form of Linux, and that's a different, older heritage style operating system, if you like. We've got Mac OS, which is really based on these Linux type operating systems that runs on our MacBooks, MacBook Airs, things like that. And then we've got a Chrome operating system, which is a Google operating system. So some of you might be familiar with the Chrome web browser. Well, the Chrome operating system is a whole system of its own. It will also run on smart devices as well. Now that's just a sample of some of the operating systems that are available for laptops, desktop computers and servers, okay? When we talk about switches and routers and firewalls like next week, they have a whole different range of operating systems that run their features as well. So basically you think the operating system is the main software that helps your IT device become useful. So it gets it to a running state that allows you to do something with it. And without the operating system, as I said before, it really is just a whole collection of bits of metal and plastic that aren't very useful. System software is mainly designed for managing the system resources, as I said. So managing the memory, The storage, so that's usually hard drive or things like your solid state drives. So that's where you store your files on your applications. And the processor, so the processor being the brains of the organization. So if we think of it in using an anatomy, a human anatomy sort of comparison, memory is like literally like our memory. Okay, so we have short-term memory and long-term memory in the human body. We have similar things in a computer system as well. So that is some things, some parts of memory will fade very quickly. Other parts of memory will stay in there for a very long time. The storage system is also really analogous to memory as well, but it's a different type of memory in that it will permanently store anything that's on it if you turn the computer off or turn the device off. Regular memory, so RAM or random access memory, that's a volatile type of storage. So when you turn the power off, whatever's in that memory will disappear. In a storage location like a hard disk or a CD, for example, if you put something on that and the power is removed, then that storage is still, that information will still be there when you turn the computer back on again. Then the processor, that's basically your brain. So that's the thing that does all the heavy lifting and all the work. System software programming is complex. And what I mean by that is if you are developing your own system software, if you're a person that works in that industry where you're writing operating systems, the programming is very complex and very difficult to do. There's a very niche market of skill sets that are used to do operating system programming. Now, if there's any of you out there who are operating system programming, first of all, I'd question why you were here in the first place. But secondly, you probably think it's really easy. And that goes really for any of these skills and sort of things that we talk about over this couple of weeks is everything's really easy when you know about it, isn't it? So computing hardware, our computer hardware, our smart devices, our tablets, our laptops, servers, whatever, they can't run without this system software. So they are totally reliant on it. Now, system software or the operating systems are completely independent and are non-reliant on the application software, which we're going to look at next. But it's not the other way around. The application software is completely dependent and reliant on the operating system. If you don't have the operating system, you have no environment in which to run your applications. So application software, on the other hand, is designed to accomplish specific tasks or functions. So it allows us to do something useful with the data or information that we have at our disposal. Programming is comparatively easy, and there's two points to make about that. In terms of developing the application software, that may actually be quite complex depending on the type of application. But programming using the applications, so if you have an application that you want to create a program using, then that's usually comparatively easy because the whole point of an application package is to allow you to perform a task in a relatively easy fashion. So yes, you might need to learn some programming language and you might need to learn bits and pieces, but it's not as complex as actually writing the application software in the start. So program the actual application software. So you can use it more easily than you can create it, in summary. The hardware can run without application software. Okay, so we can run a server or a desktop or a laptop with the operating system. We can run it and it will run perfectly fine and it will do something, but it will be limited. The functionality will be limited. That's where the application software comes in. As I said before, it is dependent on system software, specifically the operating system. So for instance, if you're running a Windows operating system, there are many different applications you can run on Windows systems, but a lot of them you may not be able to run on an Apple Mac, for example, or a MacBook, because the operating systems are very different. So you would have to get a different version of that application software. Now, some vendors, somewhere like if you think of Microsoft, for example, they will make their Office platform to run on Windows, but they also make it to run on a MacBook, for example. So that's fine, you can do that, but not all application vendors will do the same. Sometimes they might specifically write their application software for Windows, or they might write it for Mac OS, or they might write it for some version of Linux, for example. So the operating system is very important in determining what applications you are going to be able to run. And when we get to specific robotic systems, or when we talk about network devices next week and security devices next week, you'll see that that is even more important. The operating system is even more important. So we can also categorize our application software in two ways. So remember I said that, didn't I? I said we can categorize software into two, system and application. Well, now I'm going to categorize the application software in two ways. We can call them client server, or we can call them standalone, or maybe peer-to-peer. They could be sort of interchangeable terms. So client server is simply where the application software will provide a specific service, a function, or a task capability to lots of different users at the same time. Okay, so it's available for many people to use at exactly the same time. And we usually call this function a server. So we install this client server package on a server system, so a high-powered computer, if you like, and then lots of different people will be able to access that server over a network, and they'll be able to use that application at the same time from wherever they're connecting from. A standalone application is just an application that will run on a single device and allows you or provides you with some functionality or task capability to a single user at a time on a desktop. Okay, now we're not going to talk a whole lot about cloud technology, but that is now you're getting to the point where these single-use applications or standalone applications the lines are starting to become very blurred between what is client server and standalone. Now there is a crossover there, but traditionally client server will allow access to multiple people, standalone only one person at a time. So some examples of client server applications include a web server, for example. So Apache or Microsoft Internet Information Services are an example. And we might run one of those on this particular server. And you see here, we've got 3 clients. We've got a desktop computer, a tablet, and a smartphone that can all connect to this server and use that particular application. Okay, and we know that's true because you can browse the internet on your desktop, you can browse it on your Apple iPad, you can browse it on your Samsung Galaxy Android phone, all at the same time if you wanted to. That's that client-server relationship. Other examples include email servers like Microsoft Exchange is a big brand name one, but there are many others. Database servers, so Microsoft SQL Server, that's pronounced SQL, that stands for Structured Query Language. And so a database server, what a database server basically does is, and excuse me, I'm not going to explain what web and email servers are because I think everyone will be okay with those. But a database server is a server that holds a very large repository or store of information. And SQL, the structured query language, is the language that you use, the programming language that you use, if you like, to request information from that database. Okay, so it's a very specific language. There are many database languages. SQL is simply one of them. And typically in our contemporary world, clever people, much more clever than me, will write a interface that will allow you to simply enter in what you're looking for, like in a search engine, hit the search button, and behind the scenes, the SQL database or the SQL language is carrying out those instructions on your behalf. So you don't really have to know SQL language anymore, unless you're in that industry, of course. And then we have things like a customer relationship server, so something like Oracle NetSuite. So this is this is a form of database server which stores all the information that a particular business may have regarding their customer base. So as you can see, it could be really important to businesses. Standalone software applications will include things like the Microsoft Office suite, although as I said, being cloud-based now with Office 365, there's a little bit of graying of the lines there. We've got web browsers like Mozilla, Chrome, Edge, or Opera, or Opera if you want to say it that way, web browsers. We've got things like Adobe Acrobat to allow us to open PDF files. We've got what we're using tonight, Zoom, or similarly Microsoft Teams. So standalone applications that provide a single user with functionality. The interesting thing about Zoom and Microsoft Teams is that they are a standalone client, but they're interacting with the server side, okay, to provide access to this video stream to lots of different users out there. So we've currently got 350 odd, or about 350 online. And then things like Symantec Security Suite or antivirus or anti-malware type packages, okay? They're very specifically designed to protect an end host. And I'm sure there are many, many others that you can think of. The software relationship in terms of putting it all together looks like this. So we have our underlying hardware. We have our operating system, which talks backwards and forwards to the hardware to make sure that it's operating and it's working. And then it talks backwards and forwards with the application software to make sure that the application software is getting access to the memory, the processing power, and the storage that it requires. And then we've got the user interacting with the application software to do whatever it is that they want to do, whether it's write a program, write a document, send an email, browse a website, whatever it is that they may be doing. And so there's a very specific set of linkages between those four interrelated and equally important components. So hardware, what actually is hardware? So hardware is any physical device that is a component of an IT system. So we can think of it as being a computer, a laptop, a tablet device. It could be a mouse, a printer, a scanner, an external hard drive, a USB thumb drive, a microphone, a keyboard, speakers, a monitor, so on and so forth. Okay, so hardware is any piece of metal or plastic or combination thereof that is a component of an information technology system. We can also use it to refer to the components of a physical device. So if we look at this, and we've broken it down a little bit here. So we can see this image down here. This is a computer, okay, in a holistic computer. And we've got a mouse, a keyboard, a monitor, some speakers, and a microphone, which most of you will probably have experience with or have or be watching this webinar using. Inside the case, however, we have a whole range of other pieces of hardware. Okay, so we have an all-in-one reader that allows you to put memory cards, digital memory cards into your device. So maybe from a camera or something, you can put that USB key, you can put into that all-in-one reader, and that'll allow the computer to access it. There's a power supply to provide power to that device. Without that, it's going to be useless. There's a main board, or otherwise known as a motherboard. So that is simply the piece of plastic and metal and silicon that allows you to plug all these different devices into so that they can communicate with each other. So think of it as being the base layer, the foundation, if you like, of the computer. We have the CPU, or the central processing unit, which is the brain, as I said before. We've got a CPU fan, which is really important in keeping the CPU cool. So think of it as like wearing a hat on a hot day. We've got a DVD drive, okay? So to store information on a DVD disk or to read from a DVD disk. We have a solid state drive or a hard disk drive. So they are two forms of permanent storage. So when the power's off, things will still be stored on them, and they work in different ways. There's RAM, which is our memory, random access memory. So this is a volatile type of storage. When the power goes off, the RAM goes off as well. There's a VGA card. VGA stands for Video Graphics Adapter. And this is a card or a device that slots into your main board or motherboard and allows the monitor to receive a digital signal so you can see what's on your screen, what your computer's doing. And then there's sometimes there's a sound card, which allows you to plug devices in so you can hear me and I can hear you. Often, these devices can be integrated onto this main board. So in this case, they're shown as separate cards, or separate cards that will plug into this board by little slot connectors. But many times, particularly as our PCs are starting to get smaller. Or if you think about a laptop, for example, those devices are actually part of the main board. They're built into it. And so if you were to open up a laptop and pull out the motherboard or main board, it's simply a single piece of material with all of these different devices connected to it in one. It can also refer to any supporting infrastructure that an IT system has. So for example, next week, we're going to talk about some of these. So communications hardware would be a router or a switch or a wireless access point or an IP phone or a video conferencing unit, as an example. A security piece of hardware might be a firewall or an intrusion detection system. And a storage piece of hardware might be a disk array or a storage array network. And all they are just fancy terms, which basically mean that we have a whole bunch of hard drives or solid state devices, and we hook them all up together so they provide us with much more storage capacity together than they could alone. We then have a range of input and output devices, because obviously we need to input things into our digital systems in order to give them information or instructions about what we want them to do. And we have output devices which provide us with the output from those instructions or those commands that we give our devices. And there's a whole range of them here. Most of them you'll have seen, I'm assuming, at some stage. So we've got things like a microphone, which is clearly an input. So I'm talking through my headset now. I'm talking through my microphone so that you can hear me. So I'm inputting my voice, converting it into a digital signal to go across the internet, and then at your end, your speakers are your computer's receiving it, converting it into an analog sound and pushing it out through your speakers so that you can hear me. We've got our webcams, again, input device. Okay, so it takes pictures by video or still shots to be able to transmit across the internet. We've got things like headphones, so they're output devices. So you hear my voice through your headphones or through your speakers that you may have. And we've got things like our different types of monitors. So we've got our flat screen monitor, we've got our old larger cathode ray tube type monitor, CRT type monitor. But again, they are output devices. This one here is a touch screen. So it's an input and output device. So sometimes they can be both. They're not always, but they can sometimes be both. We look at this one here. This is an old fax machine. You won't see too many of these things around anymore. But if we look at it as from a telephone perspective, fax machine with a telephone connected to it, then that's an input and output device, isn't it? Because I'm talking on the telephone to someone, they're talking back to me. So I input my voice and I get output from their voice. And there's a whole range of plotters and scanners and printers. So scanners here, input device, printers and plotters are output devices. We've got a barcode scanner here, same thing, input device. We've got a projector, output device, okay? Mouse can be input and output, particularly when it's wireless, because it's getting signals back from the computer and sending them to the computer. So that can technically be an input and output device if you think of it that way. So the relationship to the user, how does all that fit in? Well, sort of like this. And this is sort of very similar to this diagram we looked at back there. Okay, it's just a little bit more expanded. So we've got our user that sits around the outside. The next layer down is the application software. So our games, our web browsers, our spreadsheets like Excel, our word processors like Word, our databases like SQL that run on top of the system software. So our operating systems, the drivers and utilities. So drivers are simply a little bit of software that the operating system uses to make sure that the video, for example, is going to work, or that the sound works, or that your mouse will work with your particular system. So they are small pieces of software that are very specific to an input or output device and make sure that they work correctly with the operating system, whereas the operating system has the overall control. And then utilities are little bits of programs that don't necessarily do a lot, but they enable you to do basic things. Okay, really simple things like might be to check that your device is connected to the internet, or to check how it's connected to the internet, whether it's wireless or wired. Or it might be, you might even count, say, Notepad Microsoft Notepad as a utility software because it allows you to write, but it's very basic and you can't do a lot with it. It's more like a utility type program. And then underneath, of course, we have our hardware, our CPU, our RAM, and our disk, which exist inside our computer device. And then we have our what are called the peripherals, so the printers and the microphones and the earphones, headphones, and the monitors that connect additionally to the main box. So if you think about this is the case is our main computer, and then all of these things that connect to that case. So all of this in here is inside the case. That's the internal hardware. Everything out here on this side are what are called peripheral devices. So they are peripheral to the main computer. And all of these here are examples of peripheral devices that you may or may not have for your computer. And really, the only things that you definitely need for a computer to be useful are something to view the output from, something to put some input into. So a keyboard and a monitor would be the absolute minimum you could get away with. A mouse would make things a lot easier, but you could use most operating systems nowadays without the use of a mouse. So that's how all that fits together. So if we look at some common computer type devices, so by definition, a compute or computer device are any electronic device that will take some input, processes them, and then will produce an output. So whether that's input from you as a user through a keyboard or mouse, or whether that's from taking information off a hard drive, for example, it will process it and then produce outputs. This could, of course, refer to any of the hardware examples we mentioned in the previous section. So some are general purpose, like your desktop computers, your laptops, tablets, and your smartphones. And others are more specialized. So digital still or video cameras, for example, gaming consoles, firewalls, switches, and routers we're going to talk about next week. They're more specialized because they have a very specific function. Smartphones, you might argue, well, they're just a phone, but no, there's so much more than that now. So what they all have in common is that they are electronic and allow us to perform a function faster than we could without their use. So you can imagine if we didn't have a smartphone or any phone of any sort, how would we communicate over long distances? Smoke signals, maybe a couple of cans with a string between them, snail mail, all old hat and out the window now, because there are much faster ways to get into communications with each other and also allow us to communicate over much greater distances, like we are this evening to those of you who are overseas. And you'll see, there's a range of items there that are, some of them are specific in nature, some of them are more general. But the common thing is they're all electronic and allow us to do things faster or to do things that we never could before. Common business devices that you will see in schools or businesses or any sort of enterprise, desktop computers and laptops, obviously, and presumably all of you are using those this evening, although some of you may be using tablets and smartphones. Printers, so devices in which you can output text to print it on a piece of paper. I fear, or I think that they will probably die out eventually when everything becomes paperless. When that occurs, I don't know, but we've been talking about paperless society for quite some time. We haven't got there yet, but I think that's probably inevitable. Scanners are devices that allow you to input, so take a piece of paper and digitize it and store it somewhere. Again, these are becoming more common, particularly in records management now. Photocopiers or multifunction devices, so allow you to photocopy, to print, maybe to fax. You can convert documents into email to send them off that way, so fax to email as well. Servers, so they are high-powered computer systems that will give us some functionality to multiple users at a time. And of course, our tablets and smartphones. So that's the basics around our hardware and our common computer devices. Then quickly, we need to have a look at our common applications. So the things that we use that allow us to provide input to or get output from our compute devices. The application software allows the computer to interact with the outside world, okay, to the real world, from the digital world to the real world. And it gives the computer a purpose and a function that's useful to us as human beings. and we use them to perform tasks that are useful within a specific context. So whether that's running our business, going to school, running a running a financial system. There's lots of different specific applications that are made to perform specific tasks. They can be generic, a bit more generic. So like a word processor, like Microsoft Word, you can do all sorts of things with that. You can write a letter, you can put some fancy graphics in it, you can insert tables, you can write an academic paper, you can do lots of things. You can insert graphics, lots of different things in the modern day word processor. Or they can be very specialized, say like a payroll application, which really only allows you to do one thing, although very, very important, and that is pay your employees or be paid yourself. Application development. So getting these applications to a point where they can be used by the outside world requires a cycle of research, analysis, development, and testing. So research about going out and asking people, users, what they want from their application. So what things do they want this application to do? We then take all that information and we analyze it, and we come up with what we think is an application that will provide the user with what they're asking for. Okay. Now I'm talking about this on a small scale, but this is clearly what places like Microsoft do. They will go and do some market research. What do our users want? They'll then analyze that, come up with a product that they think will meet the needs of the users. They'll then develop it, and then they will test it and then send it out to market. And this constantly goes on. That's why we have regular updates to our Windows operating system. We have regular updates to Office, why it's gone from, back in the dark ages when it was you bought Microsoft Word as a single application, and then Microsoft Excel, and then PowerPoint came along, and Publisher, and then they integrated them into Office, and then Office went from being a standalone product to a cloud-based product in recent times. And so they keep evaluating the needs of the users and developing it, testing it, and sticking it in the real world. So the systems analysts are the people that investigate and evaluate the requirements and processes and come up with a basic design. They then hand that over to the programmers who will develop that software using some programming language, and that is often dependent on the company and the skills that they want to invest in and the language that they want to invest in. And also to do a little bit with the operating system that they're aiming the application for. The thing to remember is that development is a really highly complex process, and all possibilities are virtually impossible to test comprehensively. And what I mean by that is, particularly with operating systems, if when they're developing Microsoft Windows, for example, they cannot possibly anticipate every single piece of hardware that someone might try to run with their operating system, with a Windows operating system. You might have a laptop that's 5 years old, or you might have a brand new laptop, or you might have a desktop computer that you've built yourself, or you might have one that you bought from a friend, or you might have something in between. And so it's virtually, with the number of hardware vendors there are now, so people making different components to build within computer systems, it's virtually impossible for Microsoft to be able to test every single combination to make sure everything is working perfectly when they send it out. And that's why we get things like bugs in software, and we get incompatibilities and things that don't always work. To give them their credit, and all operating system developers are the same, they do an absolutely incredible job at getting it right the vast majority of the time. But there are regular problems that need to be patched, that need to be fixed. And that's just part of the cycle, the application development cycle that we have to accept. Because if they spent that amount of time in making sure everything was perfect under every single possible circumstance before they released it, it would probably take 30 years before they could release a operating system. And by that time, the hardware, new hardware would have come out, and it's a never-ending cycle. They're on a hiding to nothing. And last slide for this evening, common applications by category. So these are just a few of the different applications that fit, names of applications, types of applications that fit into each of the categories. So we have word processors. So we have things like Word, Microsoft Word, OpenOffice Writer, Google Docs, WordPerfect, for example. Databases, these are some database systems here. Some of them are a little older. Clipper, I haven't seen that for a very long time, but yep, there it is.
I was going to
Multimedia.
say WordPerfect hasn't been around for a while,
No,
has it?
WordPerfect's long dead. But although,
Yeah.
having said that, I do know someone that still runs it, but it's on a very, very, very old machine. But some of these are legacy. So Clipper and FileMaker, for example, DBase are very old. Microsoft Access is still around, but Microsoft SQL is one of the bigger ones in terms of database. And then we've got companies like Oracle, which create bigger database systems again for enterprise. Anyway, we've got our multimedia, our different graphics, our web browsers, our email browsers, different games. Stick cricket's one of my favorites. I'm a cricket tragic. Socials, of course, they're all the rage now. Delivery type applications, services, applications allow you to connect to, say, for example, here in Australia, Australia Post, MyGov, PowerShop, which is a organisation that retails wholesale power services. So they buy wholesale and retail. Services Victoria. We've got our shopping, there's plenty of those, lots of them, and our productivity, different types of things we can use for productivity. And these are really, so there's 12 different categories of applications there, and that's only scratching the surface. So there are many other types of applications as well that are out there in the big wide world. So that is really a Cook's tour of IT technology, information technology. So you might think that we've covered a lot, and some of you may think we've covered often, but we've really only scratched the surface of what there is in the information technology world. Having said that, understanding the basics of hardware and software and applications and how they work together, and operating systems and how they operate and keep our systems running, how they integrate with the applications, how the applications integrate with the users, and the different types of input and output devices that are available, you have a good general understanding, a good platform upon which to base further study and further investigation. And when we come back next week and we talk about cybersecurity and networking, you'll see how some of those devices are really just a specialized computer. They're just like a specialized laptop or a specialized desktop computer. So they're built very specifically for one specific function. And that's really the only difference between a lot of these things. At the heart of it, they're all really contain the same types of components. So they have some memory, they have a brain, CPU, and they have some long-term storage. So they have short-term storage memory, long-term storage, some sort of hard drive or other long-term storage. And you'll see that's a little bit different when we get to our appliance things next week. And they have processing power. Okay, so that's the same whether it's an iPhone, a tablet, a desktop, a laptop, a switch, a router, a firewall, a wireless access point, a telephone. Doesn't matter what it is, they are made up of those same basic components. So if you have an understanding of those same basic components, you're then ready to then go and investigate the other more specialized pieces of equipment. And as I said, we'll look at some of those next week. So undoubtedly, we've probably got a few questions there. It doesn't look like too many, which is good. So either I put everyone to sleep or it's all relatively straightforward. So Shane, is there anything that that pops out at you?
I think because we're dealing with a very wide-ranging topic, we're getting now questions that are similarly wide-ranging. And one that actually stuck out for me was this one from Mr. Anonymous attendee. Given the current world we live in, what do you think is the minimum digital skills that people should have? And they have said, knowledge workers, but I think everybody is probably a knowledge worker these days.
Yeah, I think that's 100% right. So the minimum sort of skills really, and I see this, and I'll give a good example of this. I think anyway, and a place where it's really challenging, and that is, as I said before, particularly for those of us over 40 or getting into our 60s and sort of that older age bracket, it's really important even for people who are retired. My wife, for example, works for a a non-profit organisation that runs mainly on the goodwill of the fantastic volunteers that they have, and even them. So it's basically a food relief type not-for-profit, and they have volunteers come in, and at an absolute minimum, it's really important for them to understand how to generally operate a computer. So that is, turn it on for a start, understand the different input and output devices. So understand what a keyboard is and what it does, and what a mouse is and what it does, understand what a monitor is and what it does. But then on top of that, not necessarily be experts with the operating system, but understanding how to move their way around the operating system. So for example, if you want to open a file that's on the that's stored on the computer, how do you get to that? So you've got to be able to navigate through My Computer, for example, to find a hard drive, the location where the file is stored, and then be able to double click on it and open up that sort of file. You've also got to know your way around typical everyday applications. So you've got to know how to connect and browse and get access to the internet, information on the internet. That's an absolute no-brainer for anyone today. You're going to have some ability to understand the operation of a word processor, of a spreadsheet, of an email application, at an absolute minimum. If you've got those, then you can be taught how to use the more specialized information systems. So for example, if you go for a job and so you're working in an organization, and all of a sudden you've gone from not doing it, not having a job, to now working in the payroll department, for example. Now, no one would expect you to know the ins and outs of how to operate that payroll system, but they could acceptably expect you to know how to operate a computer and how to find your way around a web browser, how to use a word processor, those sorts of basic skills, which you can then take and implement in the payroll system when you start to get training around that. So I think as an absolute minimum, that is what you really need to become a knowledge worker. The more, and this is the thing that's tricky, you will get position descriptions, and it's very common for this to happen even in really in-depth technical positions, where they will list all these different skills that they want a applicant to have. Truth be known, in the vast majority of cases, not everyone are going. There's no hope that they're going to find someone with all of those skills, because if someone had all of those skills, they would be in a higher paying job somewhere else. And that's usually what happens. They put all these different skills in. So if you're going for a job and it says must have experience in this application or that application, and payroll processing, that sort of thing, for example, and you don't let that stop you from having a go at it. So long as you've got the basics of, your basic way around a computer and the operating system, you know how to start it, you know how to get access to the hard drive, you know how to run a word processor, you know how to print a document, you know how to get on the internet, know how to send and receive an email with and without an attachment, then they're the basic skills that you need. You'll be able, if you've got those, you'll be able to be trained to do anything else. And that includes, going straight from, say, school or a different industry into a technical IT position at an entry level, because those skills are transportable. So that's what you want, those basic transportable skills that you can apply anywhere.
I think there's also a growing assumption that most people have those skills from school these days, and less are organizations providing quite detailed instructions on how to use the apps, because they all assume that they've got the skill set that you're talking about. So everybody knows that most programs run in a particular sort of way, a logical fashion that's common across all sorts of programs. But there is a lot of, it's like when you swap from an iPhone to an Android phone, for example, they sort of operate the same way, but it can take you quite a long while to get into the nitty gritty and the details. And the
Yeah,
short.
exactly right. And that's what I'm saying. Those transportable skills are really useful to have, and they're things that you need to develop. And as you said, the kids coming through school now, like my kids, as they're out of school now, obviously finished at 19 and 21, but as they were coming through, they learnt the basic skills of all this, but they're still not experts. Like some of this stuff, even some of this stuff that I'm talking about tonight, although my son and daughter are very good on their iPhones and their MacBooks and their gaming consoles and that sort of thing, even some of this stuff I'm talking about tonight, they would have absolutely no clue of, because it's not something that is necessarily taught at schools even today. Yes, they have general access to a computer, and they will know how to basically operate one and the applications around it. But in terms of the going-ons inside that computer, there's plenty of people even now coming through school that will have no clue about that and never will. And that's why there will always be that need for professional IT workers. So there's a lot of potential in going into that space. But if you can, if you're here tonight and you're watching this seminar, then you've already probably got most of the skills that you need to enter into those basic entry-level positions in whatever form of work you're doing. In terms of specific skills required, that's something, particularly if you're only starting off in your working life, that are things that you're just going to build up. How else do you get experience other than by experiencing it? You can't buy that. It's just something that you have to go through. So, but if you've got those basic skills, even as I said before, as 60, 70-year-old volunteers coming into an organization, they've got lots of other life skills and industry skills that they bring along. But if they don't have those basic computer skills that enable them to clock in the morning to ensure that they're covered by insurance, or to be able to, write out the rosters, or to allocate particular drivers to particular shifts so they can go and do their food deliveries, then that's going to make that job a lot harder. So those basic skills, if you've got those, and you're pretty much set up no matter what field of endeavor you're in.
Yeah.
Sorry, Shane, that was a long answer, but yeah.
I was going to say we could get very much of the philosophy of that, because I think there's a lot in that. But there's a few more questions here, and we're going to shut down for new questions in about 1 minute. So if you've got any other things, just fire away. But Victoria has asked, is a firewall really hardware? Because really these days, it's not plastic and metal, it's more like software. And I think Samson was trying to ask the same question in a different way.
Yeah, I can be. They still certainly do exist as hardware. So when I say hardware, the hardware in a firewall is very specifically developed and tuned to act as a firewall. So, for example, if you bought a Cisco ASA firewall, for example, which is, there's various versions and models, but if you were to buy a hardware version, that's not something you could just run up Windows on and start using as a computer. It's very specifically designed to be a firewall. Or if you bought a Juniper router, for example, it's customized to be a router. And so you couldn't just run up Mac OS on it and use it in that way. So they are very specific pieces of hardware that are designed for a very specific function. Having said that, there also obviously exists now, those devices can also exist in the cloud environment, which isn't part of our overall discussion in this particular course, because it's a bit out there, a little bit more abstract. But yeah, those devices can exist in the cloud, and which they sort of call term vaporware, or they can exist in a virtualized environment as well. So no, they're not always hardware, but there always has to be some hardware underneath it to run it. Hardware it always exists. We're not at that stage yet where things are just software not running on hardware somewhere. And I can't envisage a time when, in my lifetime anyway, where that's going to happen. So yes, they do take different forms, but they do still exist in a hardware form.
I think they are separated because they're of the function. If you define it by function, that's probably as much in the hardware space.
Yes, correct.
And you probably answered this question about Nicole wants to know if you can talk about cloud, but I think we're going to do that in the future, part B of IT Basics, which will focus more on cloud applications.
Yeah, correct. So this particular 2-week course is more about some really basic sort of fundamental stuff this evening, and then some basics on cybersecurity and networking next week. So we touch a little bit on cloud next week, but yeah, not a lot. That's for another course.
Abdullah's asking, is the file system part of the system software or the application software?
Good question. That's part of the system software. So it's part of the operating system.
Boaz has asked, can VGA fit into all motherboards? I think he's trying to say, is VGA still a thing?
VGA is not still a thing. So there are definitely more advanced protocols now, if you like, or standards now. But yeah, if you were to get hold of a VGA card now, which you still can in some place, swap meets and those sort of things. Believe it or not, there's actually still a really big market in older hardware. And but they won't, and any video card is the same, any video device or any of those expansion cards are the same. You have to make sure that you have a motherboard that is able to take those, but that supports those type of cards, because there's a number of different hardware standards that have evolved over the many years, and not all motherboards are built the same, and not all devices will click into all motherboards. So no, there is definitely a very large range of choices there.
Actually, while I'm talking about Abdullah's questions, he's asked, what about OS kernel? I think that's about whether it was part of the...
Yeah, so the operating system kernel. So the kernel, if you like, is it's sort of like the if I can use an anatomy analogy again, it's like the primitive brain, what we call the primitive brain. So deep inside a human brain, we have a very small brain called the primitive brain, which is basically developed over many years of evolution. And it's the thing that sort of handles most of our autonomous type actions like breathing and heart rate and those sorts of things, the things that we don't have to concentrate on, thankfully. And the OS kernel is a bit like that. So it starts up. So it starts up after the BIOS. So the basic input output system does all the initialization, checking all the hardware's right. And then the OS kernel is that inside part of the operating system that starts to get the hardware ready to talk with the actual operating system itself. And then the part that you see in terms of Windows is that what's called an outside shell, which just allows you to interact with the hardware in a nice, easy way, rather than have to use the complexities of the operating system kernel.
The lizard brain.
Yeah.
Mr. Dell, and I'm assuming, well, actually, Mr. Dell's gone, that question. Nur Shahira has asked, is it recommended to have software applications in one client server? Is that about backup, do you think?
Maybe. In terms of where you would have your software application in a client server, so there's a number of different ways to look at it. If you're talking about individual, so an application that will run specifically for one particular user, you would normally have that on the desktop or laptop. The servers nowadays are more tuned towards things like email, web access or web-based applications, so network-based applications, or things like database servers or those sorts of things, or very specialized functions like payroll or HR or some other type of security system, for example. But you can certainly store the information on a server, and that would then allow more people to share that information. But in terms of the application itself that you're using to access that information, that is quite often on the individual workstation or device.
Okay, we've got 2 questions left that we can actually answer in the time remaining. And the rest of the questions, I suggest that you bung them in the forums, and there'll be lots of people there that can potentially answer them as we go along. Justin's asking, what would be better, do you reckon? A degree in IT, or would you just do a whole pile of CompTIA courses to get you into the industry? It's sort of right up our alley, because we actually give credit for a lot of things like CompTIA courses towards a degree.
Yeah,
So,
well, I mean, the cybersecurity fundamental subject is based on a CompTIA Security Plus, so that's certainly right up our alley. Look, I would say it depends on what you're trying to get into or how far you want to go. But I'll look at it this way: in my experience, and I'm not saying this to big note myself, but I've got a number of different academic qualifications that I've spent a lot of time, I've wasted a lot of my youth at university. And I would say a degree in information technology is really a really good starting point and a really good general entry into the field because it prepares you really well, gives you a broad range of skills to enter into the workforce at any sort of level. The certifications become more important when you start to specialize or go down a particular path, because there are many paths evidenced by what I said, I've done over the last 30 years. There are many paths which you can travel in the IT industry. And so if you find, for example, so the answer is they are both really important. And in my case, and I know many of the people that I've worked with, thousands of people that I've worked with over the years, where we would start at a university course, an undergraduate degree, and that would give us a really good broad knowledge in the area. And then once we'd got that, you go and get yourself a job, and you can start to decide, okay, which area do I want to specialize in? So do I want to specialize in security or networking or desktop support or servers, or what do I want to do? And then from that, you can choose your industry-based certifications that fit into that particular niche market, whichever way you want to go. So they're both really, really important. My advice would be go for the degree first if you've got the time and the want to stick to three or 4 years of study. Then certainly go down that path, and pick and choose your certifications as you decide which way you want to go. And what you'll find is, as you progress through your IT career, it's very unusual for someone to stay in the same little area for a long period of time. Generally, you might stay there for 5 to 6 years, and then you'll suddenly find yourself branching off into other areas. So everything's important. Any learning you can do is valuable.
Yeah, exactly. And for our lucky last question, there were a couple of late ones coming through, which we've had to push into the forum. So have a chat amongst yourselves about those. But one question was from Mr. Dell, which, as I said, I assume it's not Michael Dell. What is responsible for communication between memory and ALU?
Well, that's probably way outside the scope of IT fundamentals. So the
I thought
ALU
it might be.
is the arithmetic and logic unit, which is part of the actual central processing unit, or the brains of the computer. So effectively, there's a whole heap of circuitry and a whole heap of instructions on the CPU that controls the interaction between the memory and the arithmetic and logic unit. So the ALU is a very specific subcomponent of the central processing unit, so the main brain, that is dedicated to actually performing arithmetic and logic functions.
Well, nice to end on a curly one. I think that's it for this evening. For those of you who aren't aware, next week, same bat time, same bat channels, Wednesday the 15th at 7:30 p.m. Sydney time, we'll be going on to the next topics, which primarily revolve around networking and introducing some cyber fundamentals as well. And yeah, we look forward to having your company there. Thank you very much for attending tonight and staying with us to the end. And we look forward to speaking with you next week. Thank you very much, Matt. Thank you, Lily. Thank you, Kit.
Thank you, Shane, for your expert work as our MC tonight. Well done.
I'm just the pinch hitter, mate.
Well, it was a good job.
Thank you. Anyway, have a lovely week, everybody. We'll see you again next week.
Bye, everyone.